Okay, so now what we're going to do is go ahead and install the chain, and then we're going to check some RPMs and figure all this stuff out. Okay, so you can use this little tool here, and I'll show you how to use that here in a second. And you can have your little setup here. If you pull this pull this chain over the sprocket, oftentimes you can correspond those teeth and have this hold together in order to be able to install this. But if for some reason you can't get to that place, all right, and you end up in the situation where your two chain halves are coming together outside of the sprocket, it may be a good idea for you to use this tool right here. And basically this is how it works. We can open these jaws up, and by opening these jaws up, we can actually drop it in between a set of these rollers. Okay, and once we do that, we can bring this together with a little tension, and that can hold our chain together while we're installing our master link. But in this particular case, I have the ability to do it without that, so I'm going to go ahead and take that ability and use it. So I'm going to go here, take my chain, wrap it around the backside there, so now my sprocket engagement is helping me out, and then I can simply slide that master link in, put the plate onto the outside, and then start my clip, just like you've seen in previous videos, and then I can go ahead and snap that into engagement. So now that we have it. Okay, so what does this look like? That may look a little loose, a little tight. What is a little loose? What is a little tight? Okay, let's talk about that very briefly. I'm going to go ahead and turn this around here so you can see it a little bit better. And there is an appropriate tension for this right here, and there's a formula for it, so you're going to have to bear with me. Essentially what it is you take and find your center distance, which is roughly 16 inches, and the slop, okay, should be 4% of that distance. Okay, so what does that mean? Well, the first thing that we need to realize is for a horizontal chain drive, all right, that means that if these two sprockets are within 45 degrees of horizontal, okay, then 4% is your number. Now, if they're greater than 60 degrees, if they're the sprocket's up here, that's a vertical chain drive, and that's about 2% as far as the movement. But we're going to use 4%. So that's a very, very simple calculation. What we're going to do is 4% is 0.04. So we're going to take the calculator and go 16 inches times 0.04, and that equals 0.64. Now, 0.46 or 0.464. How do we measure that? Well, we can actually measure it with a ruler, and so what we need to find is the essentially the fractional equivalent of that, and that's very close to 5/8. So 5/8 is going to be the number here. So what does that actually look like? Well, here's what it looks like. We're going to go right on top of our rollers, okay, and then we're going to measure about in the center, and then we need to find 5/8. So this is almost 2 inches. So that's obviously not good. So in this case, we have a little adjustment that we're going to make, and we're going to bring this up. Okay, and as we bring it up, we just want to put enough tension on there that takes the slack out of that bottom chain, and I'm still over an inch, so I still need to do some adjustment here. Now I take a little bit of that slack out. It looks like I'm about 1/2 inch, so I need to go the other way some. And it looks like I'm right at 5/8. Okay, so I'm not putting a whole lot of pressure on there. I'm just, you can see at the point to where I'm taking the slack out of the bottom chain. That's all I want to do. So this right here is the appropriate chain tension for 16 inches. All right, so now that we have this loaded up, we have our chain tension set. Now what we can do is we can figure some things out. Okay, so what do we want to figure out? Well, what we want to do is get an idea of how fast this sprocket is actually turning. And what we can do is we can estimate how, or not estimate, but we can figure out how fast this is going to be turning by calculating it and then actually measuring it and see how close we are. First thing we need to know is how fast this is turning. Now in this case, this has a gear reduction on it, so we're going to have to keep in mind that there is a gear reduction on this. So whatever the motor plate says is RPM, we have to change it by whatever the ratio is. So this is a 20-to-1. So for every 20 revolutions of this motor, you're going to get 1 out of here. So that is going to determine roughly what this RPM is. But what I'm really concerned with is figuring out, in this case, how fast this is going to be turning based upon how fast this is turning. So even if it's a little bit greater or less, we can still figure that out. Now in this case right here, if we take a look at the actual sprockets themselves, we'll see The part numbers help out. It's 40 BT, so 40, that's a 40 chain series, BT 25, so that's a 25 tooth right there. And this is a 40B TV 15, so we have a 15 and a 25. So that's pretty easy. We could take the 15, 15 divided by 25, and I'm going to go ahead and do that very quickly. 15 divided by 25, and I have a multiplier. And now I'm going to have you do this, so I'm not going to necessarily give this stuff away, but essentially I can figure out by predicated on the RPMs what that's going to be. So 15 divided by 25 is actually going to be 0.6. So what that means is that let's pretend that our RPM is actually going to be, let's say, 40 RPM. Then we can multiply by 0.6, and so that would be 24 RPMs on the output. All right, now measuring it to make sure that it's right, here's how we're going to measure this. What we're going to do is open up our tachometer here, and in this particular case we're going to be using a photo tachometer, and as long as it's over on the photo, then we can shine this light wherever there is a reflective tag. There are reflective tags here and here, so it's going to be very easy for us to do that. Now, what does this all look like? Well, we'll take a quick peek. That way you can actually see what it looks like before you get your hands on it and do it. So now I'm going to go ahead, that everything is nice and safe here. I'm going to remove all of these extra tools, get those out of the way. I'm actually going to go ahead, for safety's sake, and we're going to install our guard. And then we can uninstall our lockout tagout device. Lockout tagout is off. I'm going to set that out of the way. And we're going to plug this in, and then we're going to go ahead and turn this on. All right, so now everything's working. I can't hear the chain, which is super awesome. I'm going to take my device right here, and I'm going to push the trigger, and I'm going to hold it as tightly as I can right on that reflective tape, and it's going to give me an RPM value. I'm going to jot that RPM down, okay? Then I'm going to come over here, and I'm going to do the same thing with this one, keeping my fingers and toes away from everything, and I'm going to be as steady as I can. And I'm going to take that value, and I'm going to go ahead and write that value down. All right, once I get that done, I'm going to shut this off. And before anybody else gets the chance to put their fingers in there and tear themselves up, I'm going to unplug this, put my lockout back on, along with my tag. Okay, now I'm safe. Now this is safe, and I'll take those RPMs, okay, that I've calculated, and I'm going to see how close that they actually match up. Now, the RPM from here may not necessarily match exactly what you calculated from the RPM and this because of fluctuations with the electricity. This could output slightly different, but the difference between this and this is going to be the same.